This is an example of how to find the nth term of a quadratic sequence. The steps that you take are always the same. You don't know what the sequence is, so you have to find the first difference here. Negative 12 to negative 7. Let's see, that would be adding 5. Negative 7 to negative 6, you're adding 1. Negative 6 to negative 9, you're subtracting 3. Negative 9 to negative 16, you're subtracting 7. Okay, so you found the first difference. And the first difference is not constant, and so you would say that this is not an arithmetic sequence. Okay, so we have to move on. And so the next step is to find the second difference. 5 to positive 1, well, you're subtracting 4 to get there. From positive 1 to negative 3, you're subtracting 4 to get there. And from negative 3 to negative 7, you're subtracting 4 to get there. Okay, and since the second difference is constant, that is the clue that you have a quadratic sequence. Okay, so the sequence is quadratic, and the form of that sequence is un equals an squared plus bn plus c. And I'm color coding for a reason, because the process here is to break this problem up into two parts, the quadratic part and the linear part. And so I'm first going to find the quadratic, and then I have to do the process for finding a linear sequence later on to get the linear part. Okay, so I'll color code it. So the value of a, the way you find that is you take the second difference and you divide it by 2. And it's always 2. It's not 3, not 4, it's always 2, okay? And it's that simple. And you may be wondering, well, why in the world do I divide by 2? And there's a demonstration for that, but it involves pretty complex math that I think would confuse more than help at this level, okay? If you want, you can search for that. It would be something like, why do you divide by 2 in a quadratic sequence? And you can find it. But I don't want to do that right here. Negative 4 divided by positive 2 is negative 2. And then I have the linear part. I don't know yet what that is yet. I don't know what the red is yet. But I do know that I have negative 2n squared. Okay? So to figure out the rest, you take your original value, your original... well, let's just think about this first. This is the first term in the sequence. That's the second. That's the third, fourth, and fifth. Okay? This could be the answer, but it's probably not. Okay, so you're probably not going to circle this and say, hey, this is going to represent that sequence. But let's just see how close we are. Let's find out the first, the second, the third, the fourth, and the fifth terms of this particular sequence would be. Okay, so the first term in this sequence, if I substitute a 1 in here, 1 squared is 1. 1 times negative 2 is negative 2. 2 squared is 4. 4 times 2 is negative 8. And then you have 9, negative 18. 16 is negative 32. And the fifth term would be a negative 50. Okay, so clearly this sequence doesn't represent the original at all. And so we know that this can't just be our answer, so we do have some orange to do, right? We have that linear part of the sequence that we have to attach to this equation, okay? So the way to do that is you take the original and you subtract away what you have to find out how much more we have to go. So you're going to take negative 12 and subtract negative 2. Negative 12 minus a negative. So that's negative 12 adding 2, or negative 10. So the first one there is negative 10. And then you do the same thing for all the others. Negative 7 adding 8 is 1. Negative 6 add 18 is 12. Negative 9 add 32, that would be 23. Negative 16 add 50 would be 34. This may be confusing. You may be struggling with adding integers, and I invite you to pause the video and make sure that these actually work out, okay? All right, so then you treat this just like a problem in the problem, okay? So this is another find the nth term kind of thing. So negative 10 to a 1, you're adding 11. From 1 to 12, you're adding 11. From 12 to 23, hey, check it out. It's almost like it was supposed to be like that, right? And so that's how it works. I mean, that's basically us finding the linear part now, okay? So you're adding 11. That should tell you, if you're watching this video, I'm assuming you know how to find the nth term of an arithmetic sequence. And so that's kind of where we are. And so we know our first term. So the formula for that is un equals a plus n minus 1 times d. And so the first term is negative 10. N is still n, because we don't know the specific term we're looking for. D is the common difference, and that's an 11. Okay, so you distribute the 11 into the brackets, and you get negative 10 plus 11n minus 11. And then that can simplify to be 11n. I'm going to move that 11m up front. Negative 10 minus 11 is negative 21. Okay, so there's my linear part. Okay, I'm not circling that. That's not my answer. But what's going to happen is this is going to be what I add on to the end of that equation that I'm building. Okay, so it's plus 11n minus 21. And that is what I circle. Okay, so this equation here is the formula for the nth term of this quadratic sequence. I hope that helped. Have a good day.